we find ourselves at the edge of a cosmic spectacle so immense that it defies human comprehension. Two galaxies, each containing hundreds of billions of stars, are hurtling toward one another, drawn together by the relentless pull of gravity. From our vantage point, they appear as shimmering islands of light suspended in the infinite blackness of space. Yet the reality is far more violent and chaotic. Stars are not colliding directly. Space is vast, but their gravitational forces stretch and distort entire stellar systems, twisting them into elongated streams of light, like cosmic ribbons unraveling across the void. Clouds of gas and dust, the raw material for future stars, collide with explosive energy, igniting brilliant bursts that ripple through the galaxies. In some regions, stars are flung outward, escaping the gravitational grip of their original homes, wandering alone in the darkness. The collision is slow by human standards, spanning millions of years. Yet in this prolonged chaos, there is an elegance that can only be appreciated by stepping back and witnessing the entire celestial dance. Spiral arms curl and fold, sometimes interlocking like dancers in a grand, invisible choreography, while dark lanes of dust carve shadows that make the glowing regions appear even more dramatic. Colorful bursts of blue, red, and gold punctuate the black void, each a reminder that even in destruction, there is creation. Stars born from clouds compressed by the immense pressures of galactic gravity. And yet, between these colossal, luminous entities lies something far more mysterious. A dark, empty stretch of space where light seems to falter and fade. It is here, in this void between galaxies, that the universe hides its secrets. Observers have long speculated about these gaps, but only now, with instruments capable of seeing beyond the visible spectrum, can we begin to glimpse what might be lurking there. Is it a mere shadow, the absence of matter, or could it be something entirely unexpected? Something that challenges everything we think we know about the cosmos. The anticipation builds, a sense of awe mixed with unease, as if the universe itself is holding its breath, waiting to reveal the unknown. As the galaxies continue their inexorable approach, the viewer cannot help but feel both insignificant and privileged. Insignificant because we occupy a tiny corner of a universe governed by forces beyond comprehension, and privileged because, through our instruments and imagination, we can witness a spectacle that has been unfolding for millions of years. The stage is set, the actors, stars, gas clouds, dust lanes, are in motion, and the spotlight falls on the mysterious void that beckons with questions yet unanswered. It is a scene of contrasts. Beauty and violence, chaos and order, the known and the unknowable, all converging in a cosmic drama that will challenge our perception of the universe itself. This is not merely an astronomical event. It is a story written in light and shadow, a tale of cosmic forces that shape the destiny of entire galaxies. And at the center of this narrative, suspended between brilliance and darkness, lies the space where something unexplainable awaits. As we peer into this abyss, the mind races with possibilities, each more astonishing than the last. What could exist in a place so seemingly empty yet so full of potential? The stage is set for a revelation that promises to alter our understanding of the universe, and we are only at the beginning of this extraordinary journey. The James Webb Space Telescope stands as one of humanity's most ambitious and awe-inspiring technological achievements. Launched into the cold, dark expanse of space, far beyond the interference of Earth's atmosphere, it drifts in silent orbit, a sentinel poised to reveal the hidden universe. Unlike any telescope before it, jwst is designed to observe the cosmos in infrared light, allowing it to peer through clouds of gas and dust that have long concealed the universe's deepest secrets. Its massive golden mirror, composed of 18 hexagonal segments, unfolds with delicate precision, a marvel of engineering that reflects both sunlight and human ingenuity. Each segment is aligned with incredible accuracy, creating a single, flawless surface capable of capturing faint whispers of light that have traveled billions of years across space and time. From Earth, the telescope appears as a distant symbol of possibility, yet in the emptiness of its orbit, it becomes a bridge between the known and the unknowable. With its instruments, scientists can observe the birth of stars, the collision of galaxies, and the mysterious phenomena that lurk in the shadows of the cosmos. Infrared vision allows JWST to see not just what is visible, but what has been hidden, translating faint energy into images of profound clarity and depth. It is a tool that transforms mystery into revelation, offering glimpses of a universe that has remained largely invisible until now. The power of JWST lies not only in its technology but in its mission. It is humanity's eye in the far reaches of space and time, reaching back to moments just after the Big Bang, when the first galaxies flickered to life. Each observation it makes is a step into uncharted territory, an invitation to explore phenomena that challenge existing theories and push the boundaries of knowledge. Scientists monitor its data with a mix of precision and anticipation, knowing that every faint signal might carry the key to an unprecedented discovery. As the telescope focuses on the colliding galaxies, the narrative contrasts human ingenuity with the immense scale and violence of the cosmos. Tiny instruments in space are positioned to decode events spanning millions of light-years, translating chaos into data, motion into meaning. The audience feels the thrill of potential discovery, a tension between the meticulous control of science and the unpredictable grandeur of the universe. There is wonder in knowing that, through JWST, the invisible becomes visible and the unfathomable becomes tangible. And now, as the telescope scans the void between these cosmic giants, it detects a subtle anomaly, something that does not conform to expectations. The light patterns, the shadows, the faint glimmers, all hint at an unexplainable presence. The narrative builds suspense. What is this object or signal? Is it a remnant of galactic forces, an unknown cosmic entity, or something else entirely? The stage is set for a revelation, and the audience is drawn into the anticipation, feeling the excitement and trepidation of witnessing a discovery that could reshape our understanding of the universe. The first hints of the mysterious phenomenon appeared subtly at first, like a whisper in the vast cosmic symphony. As the James Webb Space Telescope's instruments focused on the turbulent region between the colliding galaxies, scientists noticed an unusual signal, something that defied immediate explanation. It was neither the familiar glow of stars nor the diffuse light of interstellar gas, but something in between, a shadowy anomaly that pulsed faintly, almost imperceptibly, against the backdrop of swirling galaxies. At first, it was tempting to dismiss it as an artifact of imaging or a quirk in data processing, but repeated observations confirmed its presence. There it was, quietly occupying a void that should have been empty, demanding attention and curiosity. Cinematic imagery captures this anomaly as a dark ripple, a void threaded with hints of light, suspended like a specter between two colliding galaxies. In the infrared spectrum, it reveals subtle textures, shimmering wisps, irregular forms, patterns that seem to defy gravity and the expected distribution of matter. Scientists are both exhilarated and cautious, their minds racing with possibilities. Could this be a pocket of exotic matter, a newborn black hole, or perhaps something entirely unknown, unlike anything humanity has cataloged before? The lack of immediate answers amplifies the sense of wonder, casting the unknown as both a challenge and an invitation. The narrative contrasts the violent collision of galaxies with the delicate mystery floating between them. Stars are flung outward, clouds of gas ignite in brilliant bursts, and yet, at the heart of this chaos, lies a quiet enigma that does not conform to the cosmic rules observed elsewhere. It is a scene that evokes both awe and unease, as if the universe is revealing a secret it has guarded for billions of years. The anomaly's subtle glow against the darkness serves as a reminder that, even in well-studied regions, there are phenomena that remain beyond human understanding. As researchers study the data, they employ every tool at their disposal. Spectral analysis, simulations of gravitational interactions, and comparisons with previous galactic collisions. Each approach raises more questions than it answers. The anomaly does not behave as expected. Its movement, intensity, and composition all suggest that conventional models may be insufficient. The scientific community becomes a theater of suspense and speculation, with each new observation adding layers of intrigue. Hypotheses are proposed and discarded, and the sense of mystery grows, pulling the audience deeper into the story. In cinematic terms, The section immerses the viewer in a tension-filled tableau, violent galactic choreography surrounding a silent, enigmatic presence. The anomaly becomes a character in its own right, enigmatic, elusive, and compelling. Its existence challenges the familiar patterns of light and matter, prompting the viewer to contemplate not only the mechanics of galaxies, but the limits of human knowledge. By positioning this anomaly at the intersection of chaos and order, the narrative evokes awe, fear, and the irresistible pull of curiosity, setting the stage for the scientific journey and the deeper exploration that will follow. The Dance of Galaxies is a spectacle of both chaos and grace, a cosmic performance that unfolds over millions of years, yet feels almost choreographed when observed from afar. As the two massive galaxies approach each other, their spiral arms stretch and twist under immense gravitational forces, intertwining in patterns that are at once violent and mesmerizing. Stars, though separated by vast distances, seem to participate in a silent ballet, their motions dictated by the invisible pull of gravity, weaving arcs and spirals that shimmer like trails of cosmic fire against the black canvas of space. This is not random motion. It is the precise, elegant choreography of celestial mechanics, a dance written in the language of physics. Interstellar clouds of gas and dust collide with explosive energy, igniting new stars in brilliant bursts of blue-white light. Nebulas flare with intense radiance, contrasting with dark lanes of dust that obscure and shape the galactic scenery. In some regions, stars are flung outward, their trajectories bent and twisted as if swept up by invisible currents. The contrast between creation and destruction is stark. While new stars ignite, older stars may be destabilized, cast adrift into the void. This interplay of forces, destructive yet creative, is central to the drama of colliding galaxies, highlighting the paradoxical nature of cosmic evolution. The gravitational interactions also create stunning visual phenomena known as tidal tails, elongated streams of stars and gas that stretch thousands of light-years into space. These celestial ribbons trace the violent past and future paths of the colliding galaxies, like scars etched across the universe. Within these tidal tails, pockets of star formation ignite unexpectedly, providing brief flashes of color and life in the otherwise tumultuous environment. Every detail, from the sweeping arcs of light to the shadowed voids, contributes to a tableau of immense beauty and complexity, inviting the observer to marvel at both scale and subtlety. As the galaxies spiral closer, their central cores, dense with stars, gas, and dark matter, begin to interact more directly. Supermassive black holes at their centers exert a gravitational pull that can influence star clusters and gas clouds, occasionally triggering energetic jets that shoot across the void. The collision becomes a narrative of tension, with forces in constant conflict yet producing patterns of astonishing symmetry and beauty. Observers are drawn into this drama, witnessing both the destructive potential and the creative consequences of such immense energy. Amidst this grand dance, the unexplainable anomaly detected by jwst exists as a silent, mysterious participant. While stars and gas clouds engage in their violent yet graceful motions, this dark presence remains elusive, its behavior not dictated by the familiar rules that govern the galactic ballet. The contrast between the known mechanics of the colliding galaxies and the enigmatic object amplifies the sense of mystery and anticipation. Viewers are compelled to wonder, how does this anomaly fit into the cosmic narrative? Could it be influenced by the gravitational forces around it, or does it represent an entirely different phenomenon, one that challenges conventional understanding? This section immerses the audience in both education and spectacle, balancing scientific explanation with cinematic imagery. It conveys the grandeur of galactic collisions while maintaining the suspense of the unexplained. By combining vivid descriptions of motion, color, and energy with the silent tension of the anomaly, the narrative evokes awe, wonder, and curiosity, compelling viewers to follow the story deeper into the unknown reaches of the universe. Focus now shifts to the shadows in the void, the strange region of space that lies between the two colliding galaxies. Unlike the bright spirals of stars and glowing gas clouds surrounding it, this area seems almost empty, Yet the James Webb Space Telescope reveals subtle hints that something unusual occupies this seemingly vacant space. The anomaly is faint at first, a dim, irregular glow, a ripple of energy that refuses to conform to expectations. Its form is elusive, shifting slightly between observations, as if resisting classification. The darkness around it seems to deepen in contrast to the surrounding brilliance, giving the impression that the universe itself has carved out a private corner, one that is hiding secrets far beyond ordinary comprehension. Infrared imaging paints an even more intricate picture. Layers of faint light appear threaded with wisps of what might be dust or gas, but they do not behave as typical interstellar matter does. The signals fluctuate subtly, pulsing with an irregular rhythm that both fascinates and confounds astronomers. It is a cosmic riddle, a presence defined not by mass or brightness alone, but by its inexplicable patterns, lingering in a space that should otherwise be quiet. The section captures this visually, presenting the anomaly as a shadowy figure suspended in a brilliant theater, both invisible and undeniable. Scientists immediately turn to simulations and theoretical models to understand what they are witnessing. They consider gravitational effects, remnants of earlier cosmic events, and even the possibility of a phenomenon entirely new to astrophysics. Each model offers partial explanations but fails to account fully for the observed irregularities. The anomaly refuses to be neatly categorized, highlighting the limits of human knowledge in the face of the universe's immensity. This tension between expectation and observation heightens suspense, drawing viewers into the mystery while maintaining scientific credibility. Cinematic storytelling in this section emphasizes contrasts: light and shadow, chaos and stillness, the known and the unknown. While the colliding galaxies rage around it, the anomaly remains quiet, almost defiant in its isolation. It is a visual and narrative anchor, a focal point that evokes curiosity and unease simultaneously. The audience is invited to contemplate not just what this object might be, but why such mysteries exist in a universe we thought we understood. The contrast between the explosive, dynamic energy of the galaxies and the subtle, eerie presence of the anomaly amplifies emotional engagement, creating a sense of anticipation that will drive the narrative forward. As observers study the phenomenon, questions multiply. Could it be a pocket of dark matter made visible under jwst's infrared gaze? A protostructure that will evolve into a new galaxy or star cluster? Or is it something entirely alien, a form of cosmic matter or energy that has never before been detected? Each question opens the door to speculation, mystery, and wonder, inviting the audience to share in the excitement of potential discovery. In this quiet, shadowed space, the universe feels alive with possibility, a place where even the void may contain extraordinary revelations waiting to be uncovered. The concept of cosmic time travel becomes strikingly real through the lens of the James Webb Space Telescope. Unlike any human-made instrument before it, jwst allows us to look back billions of years, peering into an era when the first galaxies were forming, and the universe itself was still in its infancy. The light reaching the telescope today has traveled across unimaginable distances, passing through the vast darkness of space for eons before arriving at its precise golden mirror. Each photon captured is a message from the past, a record of events that occurred long before Earth even existed. This extraordinary capability transforms our understanding of the cosmos, allowing humanity to witness the ancient history of the universe in exquisite detail. As the telescope focuses on the colliding galaxies, it captures not only their current state but also echoes of their past interactions. The gravitational tug-of-war between them has been ongoing for millions of years, and the light we see today tells a story that began long before any human could conceive it. Infrared imaging peels back layers of dust and gas, revealing the hidden architecture of these galactic giants, including star clusters that formed in earlier epochs and voids carved out by gravitational forces. The sense of time becomes almost tangible. The audience experiences billions of years compressed into a single, vivid visual narrative, blending awe with a profound awareness of cosmic scale. This section juxtaposes human perception with the universe's immensity. While our lives unfold over decades, entire galaxies live and collide over millions of years, their motions imperceptible to the naked eye but captured in painstaking detail by jwst. There is both wonder and existential reflection in this perspective. We are witnesses to events that occurred long before our planet existed, observing phenomena that will continue long after humanity is gone. The telescope becomes a time machine, bridging epochs and connecting us emotionally and intellectually to the broader story of the cosmos. Within this temporal framework, the unexplainable anomaly takes on a new dimension of intrigue. Its existence between the colliding galaxies is not only spatially enigmatic but also temporally mysterious. Observing it through jwst's infrared capabilities allows scientists to infer how it has evolved over millions of years, yet its origin remains elusive. Did it emerge from the galaxies themselves, or is it a relic of even earlier cosmic events? Could it be a fleeting phenomenon, appearing only during this particular stage of galactic interaction, or does it exist on a timescale far beyond human comprehension? These questions deepen the narrative tension, blending scientific curiosity with a cinematic sense of suspense. The narrative evokes both awe and urgency as viewers confront the immensity of time and space. Contrasts are drawn between the fleeting nature of human life and the slow, inexorable evolution of galaxies. While the colliding giants display explosive energy and dynamic change, the anomaly appears as a persistent, enigmatic figure frozen in the stream of cosmic history. By presenting these contrasts, the section emphasizes the thrill of discovery while reinforcing the philosophical weight of observing events that stretch across billions of years. The audience is left with a profound sense of wonder, contemplating the universe not merely as a backdrop for human existence but as a vast, living narrative with mysteries that may forever challenge our understanding. Here, the narrative delves into the intricate science behind the cosmic spectacle, illuminating the forces that govern the collision of galaxies. Gravity, the invisible architect of the universe, shapes every motion, tugging at stars, gas clouds, and dark matter alike. As the two galactic giants approach, tidal forces stretch and distort their spiral arms, sending stars and gas flinging outward into vast streams known as tidal tails. These spectacular structures, sometimes spanning hundreds of thousands of light-years, serve as cosmic fingerprints, revealing the violent past interactions between the colliding galaxies. Using cinematic imagery, the section conveys both the destructive power and the underlying elegance of these gravitational forces, highlighting the paradox of cosmic creation through chaos. The physics of interstellar gas and dust adds another layer of complexity. Colliding clouds compress under intense pressure, triggering bursts of star formation that illuminate the surrounding void in brilliant flashes. Some regions remain dark, where dense clouds obscure the nascent stars, creating pockets of shadow that enhance the visual drama. These interactions are not random. They follow physical laws, yet the sheer scale renders them almost incomprehensible. By translating these abstract forces into vivid mental images, the audience can grasp the violent beauty of galactic evolution, where matter is both created and destroyed in a relentless cycle. Dark matter, the invisible scaffold upon which galaxies are built, exerts its silent influence. Though undetectable by conventional telescopes, its gravitational pull guides the motions of stars and gas, shaping the trajectory of entire galaxies. The narrative contrasts the visible brilliance of stars and nebulae with the hidden but essential presence of dark matter, emphasizing the limits of human perception and the ongoing quest to understand the universe's unseen components. This contrast between what is observed and what is inferred adds a layer of suspense and wonder, drawing viewers into the mystery while grounding the story in scientific fact. Amid these immense forces, the unexplained anomaly observed by jwst remains an enigma. Its behavior does not entirely align with existing models of gravitational dynamics, star formation, or interstellar gas interactions. Scientists are confronted with a puzzle. How does this mysterious presence fit into the larger framework of galactic physics? Spectral analysis reveals unexpected features, while simulations fail to fully replicate its properties. This tension between theoretical expectation and observed reality heightens the narrative suspense, positioning the anomaly as both a challenge and an opportunity for discovery. Cinematic storytelling is used to bridge complex science and visual awe. The section juxtaposes high-energy interactions, stars igniting, gas clouds colliding, tidal tails stretching, with the silent, persistent mystery of the anomaly. The audience experiences the drama of cosmic forces while being subtly reminded that the universe still holds secrets that defy explanation. Through this combination of vivid imagery, scientific clarity, and narrative tension, the section conveys both knowledge and wonder, preparing viewers for deeper exploration into the unknown phenomena revealed by the James Webb Space Telescope. Focus now turns directly to the signals emanating from the unexplained phenomenon, the mysterious presence caught between the colliding galaxies. Unlike the surrounding stars and gas, which shine with familiar patterns of light, this anomaly emits signals that are subtle, irregular, and enigmatic. Infrared imaging reveals faint glimmers and oscillations, almost like a heartbeat against the vast cosmic backdrop, while spectral analysis hints at unusual compositions and energy signatures. Each measurement deepens the mystery. The anomaly does not fit neatly into any known category of cosmic phenomena. Its very existence challenges expectations, forcing scientists and viewers alike to confront the limitations of current knowledge and the tantalizing possibility of something entirely new. The James Webb Space Telescope captures these signals with unprecedented clarity. Slight fluctuations in intensity, shifts in wavelength, and faint traces of motion all suggest that the anomaly is dynamic, not a mere static object. It seems to interact in subtle ways with the gravitational fields of the surrounding galaxies, yet not entirely predictably. This unpredictability amplifies both intrigue and tension. Cinematic imagery can visualize it as a pulsating, ghostly figure hovering in the void, its light faint but insistent, like a beacon calling out across billions of light years. The audience senses both its beauty and its threat, the wonder of its presence coupled with the unease of the unknown. Scientists explore multiple explanations, from dense gas clouds shaped by gravitational turbulence to protostructures that might one day become stars or galaxies themselves. Yet each hypothesis struggles to account for all observed behaviors. The anomaly's irregular pulsations, unexpected brightness variations, and peculiar spectral characteristics resist straightforward interpretation. This scientific ambiguity mirrors the cinematic tension. Viewers are invited to hold multiple possibilities in mind, knowing that certainty remains just out of reach. The narrative emphasizes the thrill of exploration and the cognitive discomfort that accompanies encountering the inexplicable. The contrast framing in this section is central to its emotional impact. Around the anomaly, the galactic collision rages with predictable physics, stars igniting and clouds of gas colliding in a brilliant display of energy. Against this backdrop of observable chaos, the anomaly's subtle, ghostly presence becomes even more compelling. It is both part of the scene and apart from it, a mystery that resists the patterns of the cosmos yet seems to exist in deliberate relation to them. This duality creates tension, wonder, and curiosity simultaneously, compelling the audience to follow the narrative further into uncharted territory. Finally, the section evokes a philosophical resonance. The signals from the anomaly remind humanity that the universe is far more complex than anticipated, that our instruments can reveal, but not yet fully explain, the hidden structures of reality. The audience is drawn into the process of discovery, witnessing firsthand the interplay between observation, hypothesis, and the persistent enigma of the unknown. Each pulse of light, each faint signal, serves as a reminder of the cosmos's boundless potential, both beautiful and unnerving, keeping viewers engaged and emotionally invested in the unfolding story. Attention now turns to the cosmic hypotheses that scientists propose to explain the enigmatic anomaly caught between the colliding galaxies. The universe is vast, and its mysteries are often stranger than fiction. The anomaly's behavior challenges established models of astrophysics, prompting researchers to consider bold possibilities. Some suggest it could be a pocket of exotic matter, material that does not interact with light or ordinary matter in conventional ways, yet exerts gravitational influence that shapes its surroundings. Others theorize it might be a nascent black hole, forming quietly in the gravitational turbulence between the galaxies, pulling in gas and dust while remaining invisible to ordinary observation. Each hypothesis is layered with both promise and uncertainty, reflecting the tension between human curiosity and the cosmos's indifferent enormity. Cinematic imagery frames these hypotheses with dramatic flair, invisible forces bending light, dark matter sculpting unseen structures, and gravity weaving a web that guides stars and gas into patterns both beautiful and deadly. The narrative emphasizes contrast, shifting between hope and fear, possibility and skepticism. On one hand, the anomaly may offer a breakthrough, revealing a hidden aspect of the universe. On the other, it could remain fundamentally unknowable, a reminder of the limits of human comprehension. Scientists debate, models are tested, and simulations attempt to replicate what is observed. Yet the anomaly continues to defy definitive explanation. This tension mirrors the audience's own anticipation, keeping engagement high and curiosity sharp. Some theories push the boundaries of conventional astrophysics. Could this be a transient phenomenon, an ephemeral structure formed only during the rare alignment of colliding galaxies? Or might it be a remnant from an earlier cosmic era, a fossil of processes that predate the galaxies themselves? Each new data point adds nuance and complexity, reinforcing both the wonder and the uncertainty. The scientific process becomes a narrative in itself, a story of human intellect grappling with phenomena that challenge not just knowledge, but imagination. In cinematic terms, the anomaly becomes a character, enigmatic, persistent, and central to the unfolding drama. The narrative also highlights the emotional stakes of these hypotheses. For the scientists observing the anomaly, each potential explanation carries both excitement and dread. A breakthrough could redefine our understanding of galactic physics, while failure to explain it might leave fundamental questions unresolved. For the audience, this mirrors the thrill of discovery, the mixture of anticipation, fear, and awe that comes with confronting the unknown. The section uses contrast framing to balance scientific rigor with narrative suspense, keeping viewers engaged while reinforcing the mystery at the heart of the story. Ultimately, the cosmic hypotheses serve as both explanation and storytelling device. They provide insight into how the universe operates while preserving the enigma that drives the narrative forward. By juxtaposing familiar physical laws with extraordinary possibilities, the section maintains tension, evokes wonder, and prepares the audience for deeper exploration. The anomaly's inexplicable nature becomes a lens through which the vastness, beauty, and strangeness of the cosmos are vividly experienced, bridging science and cinematic storytelling in a way that captivates the imagination. The James Webb Space Telescope has opened a door into a universe that is far more complex, mysterious, and terrifying than humanity ever imagined. One of its most profound revelations lies in the study of exoplanets, worlds orbiting distant stars that, until recently, existed only in theory or as faint, indirect signals. Webb allows us to examine these planets in unprecedented detail, capturing the subtle signatures of their atmospheres and the chemical fingerprints of their composition. Some of these worlds orbit stars remarkably similar to our Sun, raising profound questions about the uniqueness of our planet and the possibility of life elsewhere. The telescope reveals environments both familiar and alien, worlds that challenge our assumptions and expand the boundaries of imagination, all while underscoring the fragility and preciousness of life on Earth. Among the most striking observations are exoplanets with extreme climates and compositions. Some are gas giants, orbiting perilously close to their stars, their atmospheres roiling with superheated winds and clouds of metallic compounds. Others are rocky worlds, perhaps covered in molten lava, constantly reshaped by volcanic activity or intense stellar radiation. Webb's infrared instruments detect traces of water vapor, methane, carbon dioxide, and other molecules, offering tantalizing clues about potential habitability. Yet the more we learn, the more we confront the alien nature of these worlds. They exist in regimes of temperature, pressure, and chemical composition that strain the limits of human experience, environments that are beautiful, bizarre, and, in many ways, inhospitable to life as we know it. Some of the most unsettling discoveries involve exoplanets whose properties defy expectations. Certain planets appear to orbit in ways that challenge standard models of planetary formation, while others exhibit atmospheric compositions that suggest processes entirely unknown to science. The telescope has detected planets with dense clouds of reflective material, worlds enshrouded in thick, exotic atmospheres, and planets with climates so extreme they push the very definition of habitability. Each observation introduces both wonder and fear. Wonder at the astonishing diversity of planetary systems, and fear at the realization that the universe operates according to principles that can be profoundly alien to human intuition. Webb's ability to analyze the chemical composition of exoplanet atmospheres is particularly significant. By measuring how starlight filters through these atmospheres, scientists can detect the presence of molecules that hint at geological activity, chemical disequilibrium, or even the potential for biological processes. This technique, known as transmission spectroscopy, allows us to probe worlds that are light years away, turning faint photons into a rich narrative of planetary history. The implications are staggering. If life exists elsewhere, these observations may provide our first hints of it. Yet with each possibility comes a sobering awareness of scale and distance. Even if a planet shows signs of habitability, it may be so far away that humanity could never hope to reach it, leaving us as distant witnesses to processes we can only observe, never experience directly. The telescope also reveals contrasts that highlight both cosmic beauty and existential unease. Some exoplanets shine with serene, alien beauty, their atmospheres reflecting the light of their stars in gentle hues. Others appear hostile, violent, or chaotic, with conditions so extreme that they challenge comprehension. These juxtapositions evoke a cinematic tension. The universe is both wondrous and unforgiving, teeming with possibilities that inspire awe while reminding us of our limitations. The diversity of exoplanetary systems underscores a key truth. The cosmos is not designed with human needs or expectations in mind. It operates according to its own laws, vast and indifferent, producing worlds that are extraordinary, beautiful, and often dangerous in ways we can scarcely imagine. Philosophically, the study of exoplanets forces humanity to confront its place in the universe. For centuries, Earth has been regarded as the center of existence, a unique oasis in a cosmos of stars. Webb challenges that notion, revealing that planets are abundant, diverse, and remarkably varied, many orbiting stars much like our own. This realization can be both exhilarating and humbling. We are participants in a vast cosmic narrative, one that may extend far beyond our understanding or control. The telescope provides a mirror in which we see not only other worlds but reflections of our curiosity, our ingenuity, and our existential vulnerability. Yet Webb's exoplanet discoveries are not merely academic. They touch on deeply human questions about survival, exploration, and the search for meaning. Every observation of a distant world invites speculation. Could life exist there? Could intelligent beings gaze back at their own skies, asking the same questions we ask? And even as we ponder these possibilities, we are reminded of the fragility of our own planet, orbiting a solitary star in a vast and often inhospitable cosmos. Webb illuminates the balance between hope and fear, fascination and existential dread, revealing a universe that is at once inviting and indifferent, teeming with beauty and danger alike. Ultimately, the telescope transforms distant exoplanets from abstract points of light into intimate experiences of discovery. Each world it observes becomes a narrative, a story of formation, evolution, and survival on scales both alien and extraordinary. Webb allows us to see not only the physical characteristics of these planets but also the profound implications of their existence. The potential for life, the diversity of cosmic processes, and the unending mystery that surrounds every corner of the universe. In doing so, it challenges humanity to expand its imagination, confront its fears, and recognize its fragile but unique place in a cosmos that is vast, complex, and eternally awe-inspiring. The collision of galaxies produces a visual spectacle of unparalleled scale, a cosmic fireworks display that unfolds over millions of years yet can be captured in breathtaking detail by instruments like the James Webb Space Telescope. As the two galaxies spiral toward each other, their stars and gas clouds interact in violent yet mesmerizing ways. Clouds of interstellar gas slam together, compressing under immense pressure to ignite new stars, which flare brilliantly against the blackness of space. Nebulas erupt in vivid colors, deep blues, fiery reds, and soft golden hues, painting the void with light that has traveled millions of light-years to reach us. The chaos of collision contrasts with the serene patterns that emerge from it, highlighting the duality of creation and destruction inherent in galactic interactions. Tidal forces stretch spiral arms into elongated arcs, flinging stars outward like sparks from an unseen forge. These cosmic streams, some spanning hundreds of thousands of light-years, resemble the trailing streaks of fireworks, ephemeral yet striking in their beauty. Amidst the turbulence, regions of calm emerge, pockets where stars form slowly, dust clouds settle, and gravity gently shapes matter into nascent stellar systems. This interplay between violence and tranquility gives the viewer a sense of both awe and scale, emphasizing the immense energies at work and the intricate balance that governs the universe. The central regions of the colliding galaxies are no less dramatic. Supermassive black holes exert their influence, pulling in gas and stars while occasionally emitting energetic jets that pierce the surrounding void. These phenomena create striking visual contrasts: brilliant light against deep shadow, explosive motion against the stillness of empty space. Every flare, every eruption, becomes part of a larger narrative, a visual story that conveys both the destructive power of gravity and the creative processes it enables. The cosmic fireworks are not mere spectacle. They are evidence of forces that shape the evolution of galaxies, stars, and potentially life itself over billions of years. Amid this grand display, the unexplained anomaly detected by jwst stands in stark contrast. While stars and gas participate openly in the collision, the anomaly remains subtle and elusive, a ghostly presence that defies the surrounding chaos. Its faint glow and irregular patterns draw attention, compelling scientists and viewers alike to consider its origin and significance. The contrast between the explosive energy of the galactic fireworks and the quiet mystery of the anomaly heightens both suspense and engagement, positioning the object as a focal point in an otherwise tumultuous scene. Cinematic storytelling emphasizes these contrasts, presenting the collision not only as a scientific event, but as an emotional experience. The audience is drawn into the drama, feeling the tension between creation and destruction, order and chaos, the visible and the hidden. The cosmic fireworks ignite curiosity and wonder, while the anomaly provides a thread of mystery that propels the narrative forward. In this way, the spectacle of colliding galaxies serves both as awe-inspiring imagery and as a narrative device, reinforcing the central question: what is the nature of the unexplained presence that exists quietly amidst this grand, violent dance? The heart of the cosmic collision between the two galaxies is a scene of breathtaking complexity and raw energy. Stars are flung into elongated arcs, gas clouds compress and ignite in brilliant bursts of light, and tidal streams stretch for hundreds of thousands of light-years, sculpted by the immense gravitational forces at play. Within this tumultuous environment, the James Webb Space Telescope has detected an anomaly, an object that refuses to conform to any known astrophysical classification. At first, it is subtle, barely distinguishable against the intense luminosity of the colliding galaxies. Yet its persistent presence and unusual characteristics soon draw the attention of astronomers worldwide. This anomaly is neither a star cluster, a black hole, nor a conventional nebula. It exists in a space that challenges understanding, lying in the intergalactic void between two galaxies in violent convergence, and its discovery signals a turning point in the scientific and philosophical exploration of the universe. Cinematic visualization brings this scene to life. Imagine the galaxies in slow-motion collision, their spiraling arms twisting and stretching like rivers of stars and dust across the cosmic canvas. Supernovae flare unpredictably, casting intense bursts of light into the surrounding darkness, while interstellar gas clouds ignite in brilliant displays of color. Supermassive black holes at the centers of each galaxy expel jets of high-energy particles, slicing through the void with a violent precision that contrasts sharply with the anomaly's subtle presence. Amid this grandeur, the anomaly pulses faintly, tendrils of light extending into the surrounding gas, interacting in ways that appear both delicate and deliberate. The visual tension between explosive cosmic events and the anomaly's quiet persistence mirrors the narrative tension of the scientific investigation. A clash between the known and the unknown, the observable and the mysterious. The observational challenge posed by the anomaly is immense. Its faint luminosity requires careful calibration of instruments, multi-wavelength imaging, and spectroscopic analysis to tease out meaningful signals. Infrared observations reveal faint structures, almost ghostly in their subtlety, weaving through the dense clouds of gas and dust. Spectroscopy shows energy emissions that do not correspond to any known processes, hinting at exotic interactions or previously unobserved physical phenomena. Computational models attempt to simulate the turbulent environment of the colliding galaxies, incorporating gravitational dynamics, gas behavior, magnetic fields, and dark matter effects. Yet even the most advanced simulations fail to reproduce the anomaly's behavior fully, highlighting a gap in current understanding and pointing toward the possibility of entirely new physics. The temporal dynamics of the anomaly are equally compelling. Over months and years of observation, it exhibits slight fluctuations in brightness, subtle positional shifts, and irregular patterns that suggest an evolving structure influenced by forces not yet fully understood. These temporal changes raise fundamental questions. Is the anomaly a nascent black hole slowly accreting matter? Could it be a concentration of exotic matter interacting weakly with ordinary matter? Or is it a transient phenomenon visible only during this particular stage of galactic collision? Each hypothesis is rigorously tested against observational data and computational simulations, yet none provides a definitive explanation. The anomaly's persistent mystery drives both scientific inquiry and narrative tension, keeping audiences engaged with the unfolding story of discovery. Philosophically, the anomaly challenges assumptions about predictability, causality, and cosmic order. It serves as a reminder that even in an era of advanced observation and extensive knowledge, the universe retains phenomena that elude understanding. This confrontation with the unknown evokes awe, curiosity, and humility, compelling both scientists and viewers to consider the vastness of the cosmos and the limits of human perception. Cinematically, this philosophical tension is expressed through visual contrast. Violent galactic collisions frame the subtle glow of the anomaly, highlighting the scale of cosmic forces and the delicacy of this enigmatic object. The anomaly becomes a symbol not only of scientific intrigue but also of the mystery and beauty inherent in the universe itself. The interaction between the anomaly and its surrounding environment is particularly intriguing. Colliding galaxies generate immense gravitational forces, sending stars into tidal streams and compressing gas clouds into regions of intense star formation. Shock waves ripple through interstellar space, altering the trajectories of matter on massive scales. Yet the anomaly maintains coherence amid this chaos, subtly influencing nearby matter while resisting disruption. Could it represent a localized pocket of stabilized spacetime? Might it involve unknown forms of energy or exotic particles? These possibilities deepen both the scientific investigation and the narrative, providing hooks that sustain curiosity and engagement. Cinematically, sequences highlight this interplay. Stellar arcs flare, gas clouds erupt in vivid color, and supernovae punctuate the darkness, while the anomaly pulses with faint, mysterious light, drawing attention and evoking wonder. Scientific collaboration is central to the study of the anomaly. Observatories worldwide coordinate to capture multi-wavelength imaging, spectroscopic data, and computational models. Teams of researchers share findings, test hypotheses, and refine simulations, working collectively to understand an object that defies conventional explanation. This global effort highlights the rigor, creativity, and perseverance required in modern astrophysics, while adding a human dimension to the narrative. Cinematically, scientists become explorers navigating uncharted territory, balancing intellectual discipline with curiosity, creativity, and patience as they attempt to uncover the anomaly's secrets. The anomaly challenges existing paradigms of galactic behavior and evolution. As the James Webb Space Telescope peers deeper into the cosmos, the colliding galaxies at the heart of this investigation reveal an intricate and violent ballet of matter, energy, and gravity. Stars are flung into elongated tidal streams, massive clouds of gas twist and compress, and bursts of star formation ignite in brilliant explosions across hundreds of thousands of light-years. Yet amid this spectacle of cosmic chaos, a faint and enigmatic anomaly begins to emerge. A subtle glow that does not conform to any known stellar or galactic behavior. Initially, it is easy to overlook, almost swallowed by the grandeur of the colliding galaxies, but closer observation reveals a persistent, almost deliberate presence that refuses to be ignored. Its discovery marks the beginning of a profound scientific and philosophical journey, challenging assumptions about the universe and compelling humanity to confront mysteries that may lie beyond current understanding. Cinematic imagery provides the first layer of emotional engagement. Imagine the two massive galaxies spiraling toward one another in a slow, graceful collision, their arms stretching across the void like rivers of light and dust. Clouds of interstellar gas ignite in brilliant flashes of color, triggered by compression and turbulence. Supernovae erupt unpredictably, casting brilliant light across the surrounding darkness. Supermassive black holes at the cores of each galaxy spew energetic jets that carve through space with violent precision. Amid this dynamic, explosive environment, the anomaly persists. Its faint tendrils of light weaving subtly between the colliding arms, pulsing in irregular patterns, and interacting with nearby gas streams in ways that suggest hidden forces at work. This contrast between the violence of galactic collision and the quiet persistence of the anomaly establishes a visual metaphor for both the narrative and the scientific inquiry it inspires. The universe is simultaneously comprehensible and profoundly mysterious. The challenge for scientists lies in observation and measurement. The anomaly is faint, easily lost against the backdrop of stellar explosions and luminous gas clouds. To capture its subtle signals, researchers employ multi-wavelength imaging, including infrared, ultraviolet, and X-ray observations, seeking patterns in light, energy emissions, and structural features. Spectroscopic analysis reveals energy signatures that do not correspond to any known celestial object or process. Computational modeling attempts to simulate the turbulent environment, incorporating gravitational dynamics, magnetic fields, gas motion, and dark matter influence. Yet even the most sophisticated simulations fail to reproduce the anomaly's behavior, highlighting a gap in our understanding and signaling the possible presence of new physics. Each data point, each pulse of light, becomes a clue in a puzzle that stretches the limits of human comprehension. The anomaly's dynamic behavior deepens the intrigue. Over time, it exhibits slight variations in brightness, subtle changes in structure, and irregular pulsations that hint at complex interactions with its environment. These temporal dynamics suggest that the anomaly is not static but evolving, influenced by gravitational forces, magnetic fields, or possibly unknown energy processes. Each fluctuation is meticulously recorded, analyzed, and compared to theoretical models. Scientists test multiple hypotheses, exploring possibilities ranging from a nascent black hole forming in the turbulence between the galaxies to exotic matter interacting weakly with ordinary matter, manifesting only under very specific conditions. A third possibility is that the anomaly is a transient feature, visible only during this stage of galactic collision, a fleeting phenomenon that may vanish as the galaxies continue to merge. The persistence of unanswered questions reinforces narrative tension and sustains both scientific curiosity and cinematic suspense. Philosophically, the anomaly embodies the tension between the known and the unknown, between the measurable and the mysterious. It challenges humanity to confront the limits of perception and understanding. Despite advanced instruments and centuries of accumulated knowledge, there exist phenomena that elude comprehension, reminding us of the universe's vastness and complexity. Cinematically, this tension is visualized through contrasts. Explosive galactic collisions frame the subtle glow of the anomaly, highlighting both the scale of cosmic forces and the enigmatic, almost delicate nature of this singular object. Viewers are drawn into a dual experience: intellectual engagement with scientific mysteries and emotional resonance with the beauty and complexity of the cosmos. The anomaly's interaction with its environment is particularly compelling. Colliding galaxies produce immense gravitational stress, sending stars hurtling into tidal streams, compressing gas clouds into regions of intense star formation and creating shock waves that ripple across interstellar space. Yet the anomaly maintains coherence, subtly influencing nearby matter while remaining resilient against the violent forces surrounding it. Could it represent a localized pocket of spacetime stabilized amid chaos? Might it involve unknown energy fields or exotic particles? These possibilities deepen both the scientific inquiry and the narrative tension, offering viewers hooks that sustain engagement and fuel curiosity. Cinematic sequences emphasize this interplay. Tidal tails flare with bright gas, supernovae explode in bursts of light, and yet the anomaly pulses with a faint, mysterious glow, bridging the gap between chaos and subtlety. Scientific collaboration is essential to understanding the anomaly. Observatories worldwide coordinate observations, sharing data, cross-validating findings, and refining theoretical models. Multi-wavelength imaging captures the anomaly's behavior across different parts of the electromagnetic spectrum, while computational simulations test hypotheses against real-world data. Each new insight is incorporated into a growing framework of understanding, yet every discovery raises further questions, reinforcing the frontier nature of this investigation. Cinematically, the human element of collaboration adds depth. Scientists working together, comparing notes, hypothesizing and re-evaluating models, create a parallel narrative of human curiosity, perseverance, and ingenuity amidst the cosmic mystery. The anomaly challenges conventional models of galactic collision and evolution. Standard simulations predict the behavior of stars, gas clouds, and dark matter during such events. Yet the anomaly defies expectations. Its subtle influence, persistence, and irregular behavior suggest additional forces or phenomena may be at work. Forces or particles that have yet to be incorporated into existing physical theories. By resisting classification, the anomaly becomes both a puzzle and a catalyst for new theoretical development, inspiring scientists to explore uncharted areas of physics and cosmology. This narrative device reinforces engagement, drawing viewers into a story where every answer leads to further questions, and every observation hints at deeper cosmic truths. Emotionally, the anomaly captivates by combining subtlety with mystery. Amid the explosive backdrop of colliding galaxies, its faint glow evokes awe, curiosity, and wonder. Cinematic storytelling accentuates this effect. Stars are flung into arcs, gas clouds flare in vivid color, and supernovae punctuate the darkness. Yet the anomaly remains a quiet, luminous focal point, drawing attention through contrast. This interplay of visual spectacle and subtle mystery engages viewers on multiple levels, allowing them to experience both the grandeur of the universe and the profound intrigue of phenomena that resist comprehension. The anomaly becomes a symbol not only of cosmic mystery but of the enduring human pursuit of knowledge. Ultimately, the anomaly embodies the intersection of observation, theory, and imagination. It challenges understanding, inspires bold hypotheses, and compels both scientists and viewers to confront the unknown. Through careful observation, sophisticated modeling, and imaginative speculation, researchers strive to unravel its mysteries, while audiences share in the awe, curiosity, and intellectual engagement of exploration. Cinematically, the anomaly's faint glow persists amidst colliding galaxies, symbolizing humanity's relentless pursuit of knowledge, the complexity of the cosmos, and the profound mysteries that continue to inspire both science and imagination. By the conclusion of this section, viewers are fully immersed in the anomaly's enigma, aware that it is neither a simple phenomenon nor a static object, but a dynamic, evolving mystery that challenges our understanding of the universe and sets the stage for the deeper exploration in the subsequent sections. The James Webb Space Telescope has revealed a region of space that defies conventional understanding, lying between two massive galaxies locked in a violent, slow-motion collision. The galaxies themselves are a spectacle, enormous spirals of stars, gas, and dust twisting and stretching over hundreds of thousands of light-years, their gravitational interplay producing arcs, tidal streams, and bursts of star formation. But amid this cosmic chaos, a subtle anomaly has appeared, a faint, pulsing glow that seems almost alive, weaving through the space between the colliding galaxies. Initially overlooked, its unique spectral signature and persistent behavior soon caught the attention of astronomers. Unlike stars, black holes, or nebulae, this object does not conform to any known model, hinting at processes, forces, or forms of matter previously unobserved in the universe. It is here, in the space between colossal galactic entities, that the story of the anomaly begins to unfold in both scientific and cinematic terms. Observationally, the anomaly presents a challenge. Infrared imaging reveals faint tendrils of light, almost ghostly in their appearance, stretching and pulsing in ways that suggest subtle interactions with the surrounding environment. Spectroscopic data indicates unusual energy emissions that cannot be readily explained by known astrophysical processes. Its light does not match that of ordinary stars, star clusters, or gas clouds, nor does it resemble emissions from black holes or supernovae. These observations immediately signal that this is not a typical object in the cosmic landscape. Scientists are faced with a puzzle that requires a combination of meticulous data collection, advanced modeling, and creative theoretical thinking. Each observation deepens the mystery, drawing researchers into a process that is as much about philosophical inquiry as it is about empirical science. The cinematic potential of this scene is striking. Imagine the two galaxies colliding in a slow-motion ballet of matter and gravity. Their spiraling arms twist and stretch, luminous arcs of stars flare against the dark void, and clouds of interstellar gas ignite in bursts of brilliant color. Supermassive black holes at each galaxy's center unleash jets of high-energy radiation, slicing through the surrounding space like cosmic lances. Amid this maelstrom, the anomaly hovers, quiet, subtle, enigmatic. Tendrils of faint light extend outward, interacting with streams of gas in ways that appear deliberate, almost sentient. This contrast between violent cosmic activity and delicate, persistent mystery provides both visual drama and narrative tension, drawing viewers into the story and compelling them to ponder what forces or phenomena could produce such an extraordinary object. The anomaly's behavior over time is equally perplexing. Observations reveal faint pulsations, slight positional shifts, and irregular changes in brightness. These subtle dynamics suggest that it is not static but evolving, possibly influenced by gravitational forces, magnetic fields, or exotic energy processes. Each measurement offers a clue, yet none provides a complete explanation. Scientists construct models to simulate the environment between the colliding galaxies, factoring in the chaotic interplay of gravity, gas dynamics, and dark matter. Even the most sophisticated simulations, however, fail to replicate the anomaly's full behavior. This persistent mismatch between observation and theory underscores the frontier nature of this discovery, highlighting the limitations of current astrophysical understanding and pointing toward entirely new physics that may yet be revealed. Hypotheses about the anomaly abound. One possibility is that it represents a nascent black hole, forming quietly in the gravitational turbulence between the galaxies, slowly accreting matter while emitting irregular energy signatures. Another posits that it may be a concentration of exotic matter, interacting weakly with ordinary matter and manifesting only under specific observational conditions. A third possibility is that it is a transient structure, visible only during this particular stage of galactic collision, a fleeting phenomenon that could vanish as the galaxies continue to merge. Each hypothesis carries profound implications, not only for astrophysics but also for our understanding of the fundamental forces and constituents of the universe. The anomaly, by resisting categorization, becomes a symbol of both the cosmos's complexity and the boundless potential for discovery. Philosophically, the anomaly confronts humanity with the limits of knowledge. Despite centuries of observation and advanced instrumentation, there remain phenomena that evade full comprehension. This confrontation with the unknown evokes awe, curiosity, and humility, compelling scientists and observers alike to reconsider the assumptions underpinning our understanding of the universe. Cinematically, this tension is expressed through visual contrasts. Violent galactic collisions frame the anomaly's subtle glow, emphasizing both the scale of cosmic processes and the mysterious, almost ethereal nature of this singular object. The anomaly becomes a focal point for contemplation, a reminder that the universe is vast, intricate, and full of secrets yet to be uncovered. The temporal dimension adds depth to the mystery. Long-term observations reveal that the anomaly's luminosity, structure, and spectral characteristics fluctuate over time. These changes suggest ongoing interactions with surrounding matter or energy fields, possibly including gravitational effects, magnetic influences, or entirely unknown forces. Scientists meticulously track these variations, comparing data across months, years, and even decades to construct a timeline of the anomaly's behavior. Computational models attempt to simulate the turbulent environment of colliding galaxies, but each new observation highlights discrepancies between theory and reality, reinforcing the sense of intellectual tension and the need for further exploration. The interaction of the anomaly with its environment is particularly striking. Colliding galaxies generate immense gravitational forces that stretch stars into tidal streams, compress gas clouds into bursts of star formation, and create shock waves that ripple through interstellar space. Yet the anomaly persists, maintaining coherence amid turbulence and subtly influencing nearby matter. Could it represent a pocket of spacetime stabilized by unknown forces? Might it be a manifestation of dark energy or exotic particles? These questions deepen the scientific intrigue and provide narrative hooks that sustain engagement, blending intellectual curiosity with cinematic spectacle. The visual contrast between violent galactic phenomena and the anomaly's quiet persistence reinforces both the drama and the philosophical weight of the story. Scientific collaboration is essential for understanding this enigmatic object. Observatories around the world coordinate efforts, sharing multi-wavelength imaging, spectroscopic data, and simulation results. Teams of researchers cross-validate findings, analyze anomalies, and refine models, working collectively to piece together the anomaly's nature. This global, collaborative approach underscores the rigorous process of modern science, while providing a narrative framework that highlights the dedication, creativity, and perseverance required to probe the unknown. Cinematically, the human element adds depth to the story, portraying scientists as explorers navigating uncharted territory, both intellectually and emotionally. The anomaly challenges conventional models of galactic behavior. Standard simulations predict the motions of stars, gas clouds, and dark matter during galactic collisions. Yet the anomaly's behavior deviates from these expectations. Its subtle influence suggests additional forces or processes at work, possibly involving exotic physics or phenomena beyond current comprehension. By defying predictions, the anomaly serves as both a puzzle and an opportunity, pushing scientists to reconsider assumptions and explore new theoretical frameworks. This narrative element emphasizes the dynamic nature of discovery, highlighting the tension between expectation and revelation that drives both scientific inquiry and cinematic storytelling. Emotionally, the anomaly captivates by embodying mystery, persistence, and subtlety. Amid the violent backdrop of colliding galaxies, its quiet glow draws attention, evoking awe, curiosity, and wonder. Cinematic sequences accentuate this effect. Stars flare and gas clouds erupt in explosive color, while the anomaly pulses faintly, an enigmatic presence commanding focus despite its relative subtlety. This interplay of spectacle and subtlety engages viewers both intellectually and emotionally, allowing them to experience the grandeur of the cosmos alongside the intrigue of an object that resists understanding. The anomaly becomes a symbol of both the universe's beauty and the limits of human perception. Ultimately, the anomaly represents the convergence of observation, theory, and imagination. It challenges current understanding, inspires hypotheses, and compels scientists and viewers alike to confront the unknown. Through meticulous observation, sophisticated modeling, and philosophical reflection, researchers strive to unravel its mysteries, while audiences are invited to share in the awe, curiosity, and intellectual engagement of exploration. Cinematically, the anomaly remains a luminous focal point amid colliding galaxies, symbolizing humanity's quest for knowledge, the complexity of the cosmos, and the profound mysteries that continue to inspire both science and imagination. As this section concludes, the audience is left with a heightened sense of anticipation and wonder. The anomaly is more than a scientific curiosity. It is a narrative focal point, a visual and intellectual anchor that guides the story into deeper exploration. Its subtle glow amid the violent, chaotic backdrop of colliding galaxies emphasizes the tension between the known and unknown, the observable and the mysterious, the comprehensible and the enigmatic. By the end of this section, viewers are fully immersed in the anomaly's mystery, primed for the unfolding narrative of discovery, revelation, and cosmic contemplation that will carry them into the subsequent sections of the documentary. The James Webb Space Telescope's discovery of the anomaly between the colliding galaxies sent shockwaves through the astronomical community. At first glance, it was a faint, almost imperceptible glow, easily overlooked against the immense brilliance of the surrounding galaxies. But as astronomers focused more attention on the object, subtle patterns began to emerge, patterns in light intensity, spectral emissions, and positional shifts that defied explanation. Unlike the surrounding stars, gas clouds, and known black holes, the anomaly did not conform to any established model. It was as if a single, enigmatic brushstroke had been placed across a vast cosmic canvas, standing in stark contrast to the predictable forms and movements around it. Scientists found themselves drawn into an intellectual and emotional whirlpool, balancing meticulous analysis with the thrill of confronting the unknown. Cinematic imagery enhances the sense of wonder. The colliding galaxies themselves are breathtaking. Spiraling arms stretch like rivers of stars across the cosmic void. Massive clouds of gas ignite in bursts of star formation, and luminous arcs of dust and plasma weave intricate, almost tangible patterns. Supernovae flare unpredictably, sending waves of energy across space, while jets from supermassive black holes pierce the surrounding darkness with streaks of high-energy radiation. Against this spectacle, the anomaly hovers, subtle yet persistent, a quiet enigma amid the chaos. Its faint tendrils of light pulse irregularly, weaving through streams of gas as though it possesses an unseen influence over its surroundings. This contrast between the violence of galactic collision and the anomaly's subtle presence creates a visual and narrative tension that captivates both the mind and the imagination. Observation is painstaking and methodical. Scientists deploy every available tool to capture and analyze the anomaly, from multi-wavelength imaging to spectroscopic analysis, seeking patterns in its faint light. Over time, irregularities in brightness reveal themselves, hinting at dynamic processes at play. The spectral signature refuses to match any known celestial object, suggesting either an entirely new kind of matter or a previously unobserved physical process. Computational models attempt to replicate the turbulent environment of the colliding galaxies, incorporating gravitational interactions, gas dynamics, and dark matter effects. Yet even the most sophisticated simulations fail to fully account for the anomaly's behavior, reinforcing the sense that this is a phenomenon on the frontier of human understanding. Hypotheses proliferate as scientists attempt to categorize the anomaly. Some posit it could be a nascent black hole, quietly forming within the gravitational chaos between the galaxies, its slow accumulation of matter producing subtle energy emissions. Others suggest exotic matter or unknown energy fields, detectable only under specific observational conditions, might be responsible. Another possibility is that it represents a transient structure, appearing solely during this unique stage of galactic collision, a fleeting phenomenon that could vanish as quickly as it was observed. Each theory is rigorously tested through simulations, observational cross-checks, and theoretical modeling, but none provides a definitive answer. The anomaly's resistance to explanation reinforces its status as a symbol of the universe's profound complexity. The philosophical implications are profound. The anomaly challenges assumptions about predictability, causality, and the nature of cosmic order. It confronts humanity with the limits of knowledge, demonstrating that even with the most advanced instruments and centuries of accumulated understanding, there remain aspects of the cosmos that elude comprehension. This confrontation with the unknown evokes a mixture of awe, humility, and curiosity. It compels scientists and viewers alike to reconsider the scope of human perception and the vastness of what remains to be discovered. Cinematically, this tension is represented through contrasts. The violent brilliance of galactic collisions frames the anomaly's subtle light, emphasizing both the scale of the universe and the enigmatic nature of the discovery. Temporal dynamics of the anomaly add to its intrigue. Observations over months and years reveal slight but consistent variations in luminosity, energy distribution, and apparent structure. These fluctuations suggest ongoing processes, potentially involving interactions with surrounding gas, gravitational forces, or exotic physics yet to be understood. Scientists meticulously track these changes, using computational modeling and advanced imaging techniques to discern patterns that might illuminate the anomaly's origin and nature. Each discovery generates new questions, reinforcing the narrative tension and sustaining the viewer's engagement in both the mystery and the scientific process. The interaction between the anomaly and its environment is particularly captivating. Colliding galaxies generate immense gravitational forces, compress interstellar gas, and fling stars into tidal streams extending for hundreds of thousands of light-years. Shock waves ripple across space, triggering regions of intense star formation and turbulent energy. Amid this chaos, the anomaly maintains coherence, subtly interacting with its surroundings in ways that suggest forces or mechanisms not yet understood. Could it represent a localized pocket of space-time, stabilized amid turbulence? Might it involve dark energy or an undiscovered type of matter? These questions heighten both scientific and narrative tension, offering intellectual hooks that sustain curiosity and emotional engagement. Cinematic storytelling emphasizes contrasts of scale and energy. The colliding galaxies dominate the visual field, their spiraling arms twisting across immense distances, while the anomaly occupies a tiny fraction of space, yet commands attention through its persistent and inexplicable presence. Light and shadow interplay dramatically. Explosive star formation and luminous nebulae surround the anomaly, yet it pulses faintly, drawing focus through subtle contrast. Tendrils of light extend from the anomaly, interacting with streams of gas, sometimes fading, sometimes flaring, suggesting both fragility and resilience. This visual and conceptual tension mirrors the intellectual challenge, allowing viewers to experience both the scale of cosmic processes and the profound mystery of the unknown. Scientific collaboration is central to deciphering the anomaly. Observatories across the globe coordinate observations, sharing data, cross-validating findings, and refining models. Multi-wavelength imaging captures the anomaly's behavior across the electromagnetic spectrum, while computational simulations test hypotheses against observational data. Each new insight is carefully integrated into a growing body of understanding, yet each finding raises further questions, reinforcing the iterative nature of scientific discovery. This process is conveyed cinematically, portraying scientists as explorers navigating uncharted territory, blending intellectual rigor with curiosity, creativity, and patience. The anomaly challenges existing paradigms of galactic behavior and structure. Standard models predict the motion of matter, the formation of stars, and the gravitational interactions during galactic collisions. Yet the anomaly's persistence and subtle influence suggest additional, unrecognized processes may be at play. Its study may illuminate previously unknown aspects of cosmic physics, from dark matter interactions to exotic energy forms or localized space-time distortions. By defying expectations, the anomaly serves as both a puzzle and a catalyst, inspiring innovation, deep inquiry, and a reconsideration of long-held assumptions. Emotionally, the anomaly captivates through its quiet presence amid chaos. It evokes awe, curiosity, and a sense of wonder at the scale and complexity of the universe. Cinematic sequences underscore this emotional impact. Violent star formation and tidal distortion provide a dramatic backdrop, while the anomaly pulses gently, a subtle yet powerful focal point that engages the imagination. Viewers are drawn into both the intellectual and emotional dimensions of discovery, experiencing the tension, suspense, and exhilaration of confronting something that lies at the frontier of human understanding. Ultimately, the anomaly embodies the intersection of observation, theory, and imagination. It challenges existing knowledge, inspires bold hypotheses, and compels both scientists and viewers to confront the unknown. Through careful observation, detailed modeling, and philosophical reflection, researchers attempt to unravel its mysteries, while viewers share in the awe and intellectual engagement of exploration. Cinematically, it remains a luminous presence amid the colliding galaxies, symbolizing humanity's relentless curiosity, the beauty and complexity of the cosmos, and the profound mystery that continues to inspire exploration. As this section unfolds, the audience is left with a sense of anticipation and engagement, aware that the anomaly's mystery is far from resolved. It represents both the known and the unknowable, the observable and the incomprehensible, a focal point for curiosity and wonder. By the end of this section, viewers are fully immersed in the anomaly's enigma, prepared to follow its ongoing investigation into the deeper sections of the narrative, where revelations, theories, and cosmic truths continue to unfold in a cinematic and intellectually stimulating journey. The deeper the James Webb Space Telescope peers into the vastness of the cosmos, the more it becomes clear that the universe is not a static, predictable place, but a dynamic, ever-changing landscape of wonder, chaos, and mystery. In the violent ballet of colliding galaxies, where stars are flung across space, gas clouds collide with explosive energy, and dust lanes stretch like cosmic rivers, a subtle yet profoundly enigmatic presence has emerged. This is the anomaly, a faint, elusive object suspended between the two massive galaxies, whose quiet glow and shifting patterns resist all conventional classification. Unlike the surrounding chaos, which obeys the gravitational and physical law scientists have meticulously mapped, this anomaly behaves in ways that defy expectation. Infrared imaging reveals intricate filaments of light weaving through the darkness, delicate structures that pulse faintly and irregularly, almost as if the object were alive. Spectral analysis adds another layer of intrigue. Its energy signatures do not correspond neatly to any known type of matter or radiation, hinting at physics that may be entirely new or poorly understood. The anomaly stands as both a scientific challenge and a cinematic marvel, a quiet counterpoint to the violent brilliance of the colliding galaxies surrounding it. Cinematic visualization amplifies this contrast, transforming abstract astrophysical phenomena into a story the mind can see and feel. The galaxies themselves are ablaze with activity. Clouds of gas collide with explosive force, igniting stellar nurseries that flare in electric blues, deep reds, and soft golds. Supermassive black holes at the galactic centers emit energetic jets that pierce the interstellar medium, their light stretching across millions of light-years. Spiral arms twist and stretch under tidal forces, creating streams of stars that arc outward like glowing ribbons in a cosmic storm. Against this backdrop of violent motion, the anomaly hovers silently, almost defiantly, a subtle, ghostly presence that draws the eye and the imagination. The juxtaposition of chaos and calm is cinematic perfection, reinforcing the central tension of the narrative. In a universe of immense energy and predictable physical laws, something exists that operates outside them, challenging our understanding and captivating our curiosity. Scientists studying the anomaly are both exhilarated and cautious. Every faint flicker, every subtle variation in brightness, every irregularity in spectral data becomes a piece of an immense puzzle. Rigorous observation is combined with imaginative speculation as researchers attempt to discern its nature. Advanced simulations factor in the gravitational dynamics of the colliding galaxies, the density and movement of interstellar gas, the influence of dark matter, and even the potential role of high-energy phenomena near supermassive black holes. Yet, the anomaly refuses to conform to these models. Each simulation highlights the limitations of current understanding, revealing gaps in knowledge and suggesting the possibility of physical processes that have never before been observed. This scientific tension mirrors the cinematic tension. The audience feels both awe at the grandeur of the galaxies and unease at the anomaly's inscrutable behavior. Hypotheses regarding the anomaly's nature are numerous and bold. Some researchers suggest it could be a nascent black hole, forming quietly amid the turbulent space between the galaxies, drawing in gas and dust while remaining largely invisible except for subtle gravitational and infrared effects. Others propose it may be a dense pocket of exotic matter, a form of substance that interacts weakly with ordinary matter and light, detectable only through subtle energy fluctuations. Another possibility is that it is a transient phenomenon, visible only during this particular phase of the galactic collision, appearing as a brief window into processes that occur on a timescale of millions of years, ephemeral yet monumental. Each hypothesis carries profound implications. The discovery of exotic matter would rewrite our understanding of the universe's composition. A transient anomaly would highlight the fleeting nature of cosmic events. A nascent black hole would provide a rare glimpse into the earliest stages of galactic evolution. The narrative tension of discovery is heightened by the fact that none of these explanations fully accounts for the anomaly's observed behavior, keeping scientists and viewers alike on the edge of understanding. Beyond the scientific intrigue lies a profound philosophical and emotional dimension. Observing an object that defies comprehension forces both researchers and viewers to confront the limits of human knowledge. For millennia, humanity has sought to map, measure, and understand the heavens, believing that the universe is orderly and knowable. Yet the anomaly challenges this notion, suggesting that even amid the precision of physical law, there exist phenomena that elude categorization. Its quiet, persistent presence amid galactic chaos becomes a symbol of the unknown, evoking wonder, humility, and a sense of cosmic scale that is difficult to fully grasp. Cinematically, this is expressed through contrasts. Violent, chaotic star formation and tidal distortions surround the anomaly, while its subtle glow remains steady, almost imperceptible, inviting contemplation and reflection. The audience is drawn not just into the mechanics of galactic collision, but into the deeper emotional experience of facing something truly alien and unknowable. The anomaly's behavior over time adds yet another layer of complexity. Observations across months and years reveal slight pulsations, subtle shifts in position, and variations in energy emission. These patterns suggest a dynamic process at work, something that evolves on a timescale far longer than human observation, yet measurable through the patient accumulation of data. Researchers meticulously track these changes, analyzing light curves, spectral data, and infrared images. Sophisticated algorithms filter out noise, cosmic interference, and instrumental artifacts to isolate the anomaly's true behavior. The iterative process is painstaking, requiring international collaboration and the careful synthesis of multiple datasets. Yet each cycle of observation offers both clarity and new questions. Every answer opens the door to further mysteries, reinforcing the narrative tension and emphasizing the ongoing nature of discovery. The cosmic environment surrounding the anomaly is equally important. Colliding galaxies generate shocks, compress interstellar gas clouds, and produce gravitational waves that ripple across space-time. Stars are flung into elongated tidal tails, nebulae flare with energetic bursts, and dark matter scaffolds invisibly influence the motion of billions of stellar bodies. Amid this maelstrom, the anomaly appears to resist the surrounding forces, maintaining its presence in a way that is both mysterious and compelling. Could it be a localized pocket of stability in an otherwise chaotic environment? Might it interact with dark energy or space-time itself in ways not yet understood? These questions deepen the intrigue, highlighting contrasts between motion and stillness, predictability and mystery, and the known and unknown. Cinematic storytelling emphasizes the visual and emotional contrasts inherent in these phenomena. The galaxy's chaos is rendered in vivid, almost painterly detail. Stars ignite and die, gas clouds collide in spectacular flares, and tidal streams arc gracefully through space. Against this tumult, the anomaly's subtle glow offers a counterpoint, a quiet mystery that both captivates and unnerves. Light and shadow, motion and stillness, chaos and calm, all work together to immerse the audience in a universe that is beautiful, violent, and unfathomably vast. The narrative tension is carefully calibrated. Viewers experience the drama of cosmic forces while simultaneously being drawn into the enigma of the anomaly, maintaining engagement through both intellectual curiosity and emotional resonance. Philosophically, the anomaly prompts reflection on humanity's place in the cosmos. In witnessing an object that defies understanding, viewers confront the vast scales of time and space, the limits of perception, and the possibility that the universe contains phenomena beyond imagination. It highlights the dual nature of scientific exploration, the exhilaration of discovery tempered by the humility of acknowledging what cannot yet be known. The narrative uses this tension to elevate the story beyond astrophysics, connecting the audience emotionally to the awe, wonder, and even fear that comes with encountering the unknown. The investigative process itself becomes a narrative element. Scientists employ multispectral imaging, simulations, and predictive modeling to attempt to decipher the anomaly's properties. They compare its behavior to known cosmic phenomena, analyze subtle gravitational influences, and track changes over time. Each step is depicted cinematically, with visualizations showing energy flows, star movements, and gravitational distortions, creating a sense of active exploration. The audience witnesses the painstaking, iterative nature of real science, the excitement of incremental discovery, and the tension that arises when the universe refuses to provide simple answers. The anomaly also challenges the boundaries of current theoretical physics. If it represents a new form of matter or energy, or a localized distortion in spacetime, it could have profound implications for cosmology, astrophysics, and fundamental physics. Scientists must consider possibilities that extend beyond traditional frameworks, incorporating speculation, hypothesis testing, and open-ended inquiry. The narrative emphasizes this intellectual frontier, portraying the anomaly as a bridge between the known universe and the vast, uncharted territories of possibility. Finally, the anomaly's quiet persistence amid cosmic chaos underscores the overarching theme. The universe is both comprehensible and unfathomably mysterious. Through its subtle glow, irregular pulsations, and defiance of conventional laws, it embodies the tension between order and mystery, science and wonder, observation and imagination. Cinematically, scientifically, and philosophically, it becomes the narrative focal point, compelling viewers to confront the enormity of the cosmos, the limits of human understanding, and the thrill of encountering something entirely new. By weaving together observation, theory, and emotion, this section immerses the audience fully in the wonder, suspense, and intellectual excitement of one of the universe's most enigmatic phenomena, setting the stage for the revelations, debates, and discoveries yet to unfold. The colliding galaxies continue their cosmic dance, a slow-motion ballet spanning millions of years, and amid this chaos, the anomaly detected by the James Webb Space Telescope grows ever more intriguing. As scientists observe its subtle luminosity and faint pulsations, it becomes clear that the object is not a static feature but a dynamic presence, evolving over time in ways that challenge conventional astrophysical understanding. Infrared imaging reveals delicate tendrils of light extending from the anomaly, intertwining with gas streams from the galactic collision, as though it is interacting with its surroundings in an intricate, almost purposeful manner. Spectral data confirms this complexity. Energy emissions fluctuate irregularly, showing patterns inconsistent with stars, gas clouds, or known black hole behavior. Each new observation deepens the mystery, compelling researchers to confront the possibility that they are witnessing a phenomenon entirely outside known cosmic norms. Cinematic visualization heightens the drama. The galaxies themselves are ablaze with energy. Massive clouds of gas collide and ignite in bursts of new star formation. Supernovae flare with violent brilliance, and spiral arms twist into elongated tidal streams that stretch across hundreds of thousands of light-years. Amid this grand, chaotic spectacle, the anomaly hovers, quiet and subtle, its presence both fragile and resilient. Light pulses faintly along its edges, shifting in intensity and color, giving the impression of an object alive in its own right. The contrast between the galaxy's explosive activity and the anomaly's measured, almost ethereal behavior creates a visual tension that mirrors the intellectual challenge faced by the scientists, drawing the audience into both the beauty and the mystery of the cosmos. Scientists respond to this enigma with a combination of rigorous observation, computational modeling, and theoretical speculation. The anomaly's faint signals are painstakingly analyzed over time. Brightness variations are charted, spectral data is cross-referenced with known cosmic objects, and infrared signatures are compared to simulations of interstellar phenomena. High-resolution models attempt to replicate the gravitational, hydrodynamic, and energetic environment between the colliding galaxies, yet none fully capture the anomaly's behavior. Its subtle motion, unpredictable pulsations, and spectral anomalies resist replication, suggesting the presence of physical processes that remain unknown. Each failed simulation is not a disappointment but a clue, pointing toward the limitations of current knowledge and the possibility of entirely new physics. Hypotheses about the anomaly abound, each with its own set of tantalizing implications. Some researchers propose that it could be a nascent black hole, forming in the turbulent gravitational environment between the galaxies, drawing in matter slowly while emitting energy in a subtle and irregular fashion. Others suggest it might be a region of exotic matter, detectable only under specific observational conditions, its composition unlike anything catalogued before. Another possibility is that the anomaly is a transient structure, visible only during this unique stage of galactic collision, a fleeting event that exists for mere millions of years before dissipating or transforming into something else entirely. Each hypothesis provokes vigorous debate, simulations, and detailed observation, and yet none offers a definitive explanation, leaving the anomaly as an enduring puzzle that resists categorization. The emotional impact on the scientific community is profound. Observers are caught between exhilaration and humility, exhilaration at witnessing an unprecedented phenomenon, and humility at the realization of the universe's vast unknowns. Every small discovery, an unusual pulse in brightness, a shift in spectral energy, or a subtle motion, sparks excitement and invites further inquiry. Simultaneously, the anomaly's defiance of known physical laws evokes a sense of cosmic awe, reminding researchers and viewers alike that even the most advanced instruments cannot fully capture the complexity of the universe. Cinematically, this tension is conveyed through juxtaposition. Violent galactic collisions unfold in vibrant color and motion, while the anomaly glows faintly, almost imperceptibly, inviting contemplation and a sense of mystery. The interaction between the anomaly and its galactic environment is particularly striking. The colliding galaxies generate immense gravitational forces, compressing gas clouds, flinging stars outward, and creating shock waves that ripple through space. Yet the anomaly appears largely unaffected, maintaining a presence that is both persistent and enigmatic. Could it be stabilized by forces unknown to current physics? Does it interact with dark energy or some other exotic aspect of the cosmos? These questions deepen the intrigue, drawing viewers into the scientific process and highlighting the contrast between observable phenomena and unexplained anomalies. The narrative emphasizes suspense, curiosity, and intellectual engagement, keeping the audience invested in the unfolding story. Cinematic storytelling further enhances this section by focusing on visual and sensory contrasts. Violent, high-energy events, exploding star clusters, twisting spiral arms, and luminous nebulae surround the anomaly, whose subtle glow serves as a counterpoint, drawing attention through its calm persistence. Light and shadow, motion and stillness, chaos and order, all interplay to create a visually arresting tableau. The anomaly's delicate tendrils of light stretch into the surrounding galactic material, sometimes fading, sometimes flaring, suggesting both fragility and resilience. This visual tension mirrors the intellectual tension of scientific investigation. The anomaly is both known and unknown, observable yet inexplicable, captivating the mind while defying easy understanding. The philosophical dimensions of the anomaly are equally profound. In confronting an object that resists classification, humanity is reminded of its own limitations. Even with the most advanced technology and centuries of accumulated knowledge, there remain aspects of the cosmos that are fundamentally beyond comprehension. The anomaly becomes a symbol of the unknown, inviting reflection on the scale, complexity, and strangeness of the universe. It evokes feelings of humility, wonder, and awe, challenging assumptions about the predictability of cosmic order and emphasizing the vastness of what remains to be discovered. For viewers, this enhances emotional engagement, transforming the anomaly from a scientific curiosity into a source of philosophical contemplation. As the investigation progresses, the anomaly's temporal behavior adds another layer of complexity and intrigue. Observations conducted over months and years reveal small, irregular pulsations and shifts in energy emission. Scientists track these variations meticulously, mapping subtle changes in brightness, spectral signatures, and apparent motion. Advanced algorithms help filter out cosmic noise and instrumental artifacts, ensuring that observed variations reflect genuine phenomena rather than observational errors. This long-term monitoring not only informs hypotheses about the anomaly's origin and nature, but also emphasizes the patience, rigor, and dedication required for real scientific discovery, further immersing viewers in the process. The anomaly's presence also challenges existing models of galactic evolution. Standard simulations predict how matter should behave during collisions, stars forming, gas clouds compressing, and dark matter shaping gravitational fields. But the anomaly does not conform neatly to these predictions. Its persistence and subtle interactions suggest processes not accounted for in current models. This forces scientists to reconsider assumptions, explore new theoretical frameworks, and push the boundaries of astrophysics. Cinematically, this can be represented through visualizations of the anomaly bending or influencing surrounding matter in unexpected ways, suggesting forces or interactions that are invisible yet profoundly real. The narrative tension created by this unknown reinforces curiosity and engagement, keeping viewers invested in the mystery. Interwoven with the scientific and philosophical aspects is an emotional narrative that heightens the cinematic experience. The anomaly's quiet, persistent glow evokes a sense of wonder and suspense, standing in stark contrast to the explosive energy of the colliding galaxies. Viewers experience a mixture of awe and tension, drawn into the unfolding drama as scientists attempt to decipher an object that defies comprehension. This dual narrative, scientific rigor paired with cinematic tension, ensures that the audience remains fully immersed, both intellectually and emotionally, as the anomaly becomes the focal point of discovery, speculation, and imagination. Finally, the anomaly embodies the intersection of observation, theory, and human curiosity. It is a tangible representation of the unknown, challenging assumptions, inspiring hypotheses, and compelling scientists and viewers alike to expand their understanding of the cosmos. Through meticulous study, advanced simulations, and careful observation, researchers attempt to reveal its secrets, yet each discovery leads to new questions. Cinematically, the anomaly remains a haunting, luminous presence amid the vastness of space, its quiet persistence symbolizing the endless frontier of exploration. By weaving together detailed scientific explanation, immersive visual storytelling, and emotional resonance, this section fully captures the complexity, mystery, and awe of one of the universe's most enigmatic phenomena, setting the stage for further revelations and discoveries to come. The universe, as observed through the lens of the James Webb Space Telescope, reveals both a grandeur that captivates the imagination and a complexity that defies comprehension. The colliding galaxies, immense in scale and violent in motion, serve as the stage for a drama unfolding over millions of years, and amid this cosmic theater, the anomaly between them has emerged as a puzzle of unprecedented significance. Unlike the vast majority of objects we can categorize, stars igniting, gas clouds forming nebulae, black holes consuming matter, this subtle presence resists conventional explanation. Infrared imaging reveals faint tendrils of light, delicate filaments that pulse irregularly, intertwining with streams of galactic material, as if guided by forces not yet understood. Its spectral signature does not correspond neatly to any known type of matter, suggesting an entirely new or exotic physical process at play. The object stands as both a scientific enigma and a visual focal point, inviting contemplation, study, and cinematic awe. Cinematic visualization emphasizes the tension inherent in this scene. The colliding galaxies are ablaze with energy. Massive clouds of gas compress violently, triggering bursts of star formation. Tidal forces stretch spiral arms into elongated arcs that span hundreds of thousands of light-years. Supermassive black holes at galactic centers emit jets of radiation that pierce the surrounding medium. Against this turbulent, luminous backdrop, the anomaly hovers silently, its faint glow a subtle counterpoint to the explosive activity around it. The contrast between chaos and calm, violent energy and quiet persistence, serves not only as a visual spectacle but as a narrative device, drawing the audience into the mystery and compelling them to contemplate forces that remain beyond our comprehension. The anomaly's behavior challenges every expectation. Observations over time reveal slight pulsations, faint shifts in position, and fluctuations in energy emission, suggesting that it is not static but dynamic, evolving in a manner that conventional physics struggles to predict. Its interactions with surrounding gas clouds appear to defy gravitational expectations. It maintains a coherence amid turbulence that should, by all current models, disrupt it. Infrared and spectral data provide tantalizing hints, showing energy distributions that are unusual for standard astrophysical processes. The anomaly's persistence in such a violent environment suggests either an unprecedented stability mechanism or a form of matter or energy not yet understood. Each observation deepens the mystery, creating narrative tension that is both intellectual and emotional. Scientists respond with a combination of meticulous observation, sophisticated modeling, and rigorous hypothesis testing. Every faint signal is analyzed. Brightness variations are charted, spectral anomalies compared with theoretical predictions, and infrared images cross-referenced with simulations of galactic collisions. High-resolution computational models attempt to reproduce the environment between the galaxies, incorporating gravitational dynamics, hydrodynamic interactions of gas, and the influence of dark matter. Yet no model fully accounts for the anomaly's behavior. Its subtle pulsations, irregular energy signatures, and apparent interactions with surrounding matter remain elusive, highlighting gaps in our understanding and suggesting new physics may be required. This scientific struggle mirrors the narrative tension of the story, offering a compelling portrayal of the frontier of discovery. Multiple hypotheses have emerged, each carrying profound implications. One suggests the anomaly could be a proto-black hole, forming quietly in the gravitational turbulence between the galaxies, accumulating matter slowly while emitting irregular energy patterns. Another posits a concentration of exotic matter, detectable only under specific conditions and perhaps interacting weakly with normal matter. A third possibility is that the anomaly represents a transient phenomenon, appearing only during this particular phase of galactic collision, a fleeting glimpse into processes that occur over millions of years. The investigation is painstaking and iterative. Observers track every faint pulse, map spectral anomalies, and monitor shifts in position over months and years. Advanced algorithms filter out cosmic noise and instrumental artifacts, ensuring that variations reflect genuine phenomena. International collaboration is crucial, as researchers across the globe pool data, simulations, and expertise to construct the most comprehensive understanding possible. Each cycle of observation brings incremental insight while simultaneously raising new questions. This ongoing process mirrors the scientific method itself, emphasizing patience, rigor, and the thrill of discovery in a landscape where answers are rare and fleeting. Cinematic storytelling amplifies these elements through visualization. Light and shadow, motion and stillness, chaos and calm, all work in concert to immerse viewers. The galaxy's spiraling arms twist and stretch in brilliant arcs, stars ignite and collapse in brilliant bursts, and tidal tails flare with glowing material, yet the anomaly maintains its quiet presence. Tendrils of light extend and recede, pulsing irregularly, interacting subtly with nearby gas streams. These visual contrasts create both intellectual and emotional engagement. Viewers are drawn into the spectacle, awed by the scale and beauty of the galaxies, while simultaneously intrigued and unsettled by the anomaly's inexplicable nature. The anomaly's interactions with its environment are particularly compelling. Colliding galaxies generate shock waves, compress interstellar gas, and fling stars outward with tremendous force. Yet the anomaly persists with an integrity that defies expectations, as if governed by forces or structures beyond current understanding. This raises questions about the nature of matter, energy, and spacetime itself. Could it be a localized pocket of stability amid chaos? Might it involve interactions with dark energy or an undiscovered form of cosmic force? These possibilities expand the scope of inquiry, inviting viewers to consider the limits of human knowledge and the potential for entirely new physics to exist in the universe. Philosophically, the anomaly exemplifies the tension between the known and the unknown, between human understanding and cosmic mystery. Its subtle glow against the violent backdrop of galactic collision evokes awe, humility, and wonder. It reminds us that even in an era of unprecedented technological capability, the universe retains secrets that resist full comprehension. This emotional resonance is central to the narrative. The anomaly is not merely a scientific curiosity but a symbol of the vastness, complexity, and beauty of the cosmos. The narrative also emphasizes the anomaly's temporal dynamics. Observations over long periods reveal changes in energy emission, faint structural shifts, and possible interactions with surrounding matter. These dynamics suggest the object is not a static relic but an evolving phenomenon, possibly influenced by forces not yet understood. The meticulous tracking of these changes is rendered cinematic through visualizations of pulsations, energy flows, and subtle motion, allowing viewers to perceive the passage of cosmic time and the unfolding complexity of the anomaly. Cinematic storytelling also underscores contrasts of scale. The galaxies span hundreds of thousands of light-years, yet the anomaly occupies only a tiny fraction of this space. Its subtle glow is dwarfed by the immense energy of supernovae, the brilliance of star clusters, and the stretching arcs of tidal streams. Yet paradoxically, it commands attention, drawing focus through its mystery and resistance to explanation. This visual and conceptual contrast reinforces the narrative tension, highlighting both the enormity of cosmic processes and the profound significance of the unexplained anomaly. Scientific investigation proceeds along multiple fronts simultaneously. Observations are conducted in various infrared wavelengths to detect subtle energy patterns. Spectral data is analyzed for irregular emission lines. Computational models simulate the complex gravitational and hydrodynamic environment of the colliding galaxies. Every piece of data is cross-referenced and scrutinized to distinguish genuine anomalies from artifacts or coincidences. The process is iterative, complex, and painstaking, reflecting both the rigor of modern astrophysics and the patience required to probe phenomena that are subtle, distant, and fleeting. Through this depiction, viewers are immersed not only in the cosmic spectacle but in the human endeavor of scientific exploration. The anomaly also challenges assumptions about galactic evolution and structure. Standard models predict how matter behaves during collisions. Gas clouds compress, stars are flung outward, and gravitational forces shape large-scale structures. The anomaly's persistence and subtle interaction with surrounding matter suggest additional processes at work, potentially revealing aspects of cosmic physics previously unobserved. Its study may have implications for understanding dark matter, energy distribution, or even the fundamental structure of spacetime. The narrative emphasizes this frontier aspect, portraying the anomaly as both a puzzle and a guide to deeper cosmic truths. Emotionally, the anomaly captivates the imagination. Its quiet persistence amid explosive activity evokes wonder and suspense. Cinematic sequences emphasize this. Flaring nebulae and twisting star streams form a dramatic backdrop, while the anomaly pulses softly, an almost living presence that invites contemplation. This interplay of spectacle and subtlety engages both intellect and emotion, ensuring that the audience remains immersed in the narrative and invested in the mystery. Ultimately, the anomaly represents the intersection of observation, theory, and imagination. It challenges understanding, inspires hypotheses, and compels both scientists and viewers to confront the unknown. Its study exemplifies the thrill of discovery, the patience of investigation, and the awe of encountering a phenomenon that transcends existing knowledge. Through vivid description, scientific rigor, philosophical reflection, and cinematic visualization, this section immerses the audience in one of the universe's most compelling mysteries, emphasizing both the beauty and the profound complexity of the cosmos. By the end of this section, viewers are left with a sense of awe, curiosity, and anticipation, primed for the revelations and challenges yet to unfold in the continuing investigation of this enigmatic object. As the James Webb Space Telescope continues to observe the cosmos, the anomaly between the colliding galaxies becomes increasingly enigmatic, defying conventional understanding and capturing the imagination of scientists and the public alike. While the galaxies themselves engage in a violent, chaotic dance of gravity, gas, and stars, the anomaly exhibits a persistence and subtlety that stands in stark contrast to the surrounding turbulence. Infrared imaging reveals delicate, almost ethereal filaments of light that weave through the darkness, pulsing irregularly and interacting with the streams of matter expelled by the colliding galaxies. Spectral analysis shows energy signatures that do not correspond to any known celestial object, suggesting the possibility of entirely new forms of matter or energy. This anomaly, small in scale yet monumental in significance, has become the focal point of a cosmic mystery that challenges the limits of human knowledge. Cinematic visualizations emphasize the stark contrast between the violent collision of galaxies and the anomaly's quiet persistence. Stars are flung across space in elongated tidal tails, nebulae ignite in brilliant bursts of color, and supermassive black holes at the galactic cores release jets of radiation that pierce the surrounding medium. Amid this spectacle, the anomaly hovers, its faint glow a subtle counterpoint to the explosive activity around it. The contrast between chaos and calm, brilliance and subtlety, serves as a narrative device, drawing viewers into both the beauty of the universe and the profound mystery of this inexplicable object. This visual tension mirrors the intellectual tension faced by scientists, who are both awed and confounded by the anomaly's presence. Observational efforts are meticulous and exhaustive. Scientists track every faint pulse, map spectral irregularities, and monitor even the smallest shifts in position over months and years. Advanced algorithms filter out noise, cosmic interference, and instrumental artifacts, ensuring that variations observed are genuine. International collaboration allows researchers to compare data, cross-validate findings, and refine models, creating a comprehensive understanding of the anomaly's environment. Yet, with each new observation, the anomaly continues to defy expectation. Its subtle pulsations and irregular energy emissions suggest processes not accounted for by current astrophysical theory, highlighting the frontier of discovery and the inherent uncertainty of exploring phenomena that exist at the limits of perception. Multiple hypotheses attempt to explain the anomaly's nature, each with profound implications. One suggests it may be a nascent black hole forming quietly amid the gravitational turbulence of the colliding galaxies, drawing in matter gradually while emitting irregular energy. Another hypothesis proposes that the anomaly is a concentration of exotic matter, interacting weakly with ordinary matter and detectable only through subtle infrared and gravitational signals. A third possibility is that the anomaly is a transient phenomenon, visible only during this specific stage of galactic collision. A fleeting glimpse into processes that occur over millions of years, ephemeral yet profound. Each hypothesis is rigorously tested through simulations, observation, and theoretical modeling, but none fully accounts for all the anomaly's characteristics, leaving it as a symbol of the universe's boundless complexity and mystery. The anomaly's presence prompts reflection not only on the nature of the universe but on humanity's place within it. Observing an object that resists classification challenges our assumptions about the predictability of cosmic order and underscores the limits of human knowledge. Even with advanced technology and centuries of accumulated understanding, the universe retains secrets that confront us with humility and awe. Cinematically, this tension is expressed through contrasts. The violent energy of colliding galaxies surrounds the anomaly, whose subtle glow and persistent form invite contemplation and wonder. The narrative weaves together intellectual engagement and emotional resonance, ensuring that viewers are both informed and deeply moved by the cosmic drama unfolding before them. Temporal dynamics further complicate the anomaly's study. Long-term observations reveal slight but persistent changes in luminosity, spectral energy, and apparent structure. These dynamics suggest that the anomaly is not static but evolving, interacting with its environment in ways that remain poorly understood. Researchers track these changes meticulously, using high-resolution imaging and multi-wavelength observations to map fluctuations over time. Computational models attempt to simulate the complex interplay of gravitational forces, gas dynamics, and energy distribution, yet none fully reproduces the anomaly's behavior. This ongoing process of observation, modeling, and reinterpretation exemplifies the iterative nature of scientific discovery and underscores the anomaly's role as a catalyst for expanding our understanding of the cosmos. By defying expectations, the anomaly acts as a catalyst for theoretical innovation, prompting scientists to expand their models and consider new possibilities that could fundamentally alter our understanding of the cosmos. Emotionally, the anomaly captivates both scientists and viewers. Its subtle glow amid explosive galactic activity evokes awe, wonder, and curiosity. Cinematic sequences highlight this interplay. Tidal tails flare with luminous gas, supernovae erupt in brilliant color, and stars stream across space, while the anomaly pulses faintly, drawing the eye and the imagination. This dual narrative, scientific investigation paired with cinematic spectacle, ensures deep engagement, allowing viewers to experience both the intellectual challenge and the emotional resonance of encountering the unknown. The anomaly's discovery also emphasizes the iterative and collaborative nature of modern science. Observations are conducted across multiple wavelengths. Spectral lines are analyzed for irregular patterns, and computational simulations attempt to reproduce the anomaly's environment. International teams coordinate data collection and analysis, cross-validating findings to construct a comprehensive picture of the object. Every new data point is scrutinized, compared, and tested against competing hypotheses. The narrative conveys this process cinematically, portraying scientists as explorers navigating uncharted territory, highlighting the human element of curiosity, persistence, and ingenuity. Philosophically, the anomaly serves as a mirror for humanity's relationship with the universe. It embodies the tension between knowledge and mystery, comprehension and wonder. In a universe where galaxies collide, stars are born and die, and black holes consume matter with relentless inevitability, this small, persistent anomaly resists understanding. It reminds us that no matter how far our technology and intellect advance, there are aspects of the cosmos that will always elude complete explanation. This realization evokes humility, fascination, and a profound sense of awe, reinforcing the emotional core of the narrative. The temporal evolution of the anomaly adds layers of suspense and complexity. Observations over extended periods reveal subtle variations in brightness, energy distribution, and structural configuration, suggesting ongoing interactions with surrounding matter or energy fields. Computational modeling attempts to simulate these changes, exploring scenarios ranging from gravitational stabilization to exotic matter dynamics. Each simulation provides insight yet fails to fully account for all observed phenomena, maintaining a tension that sustains both scientific curiosity and narrative engagement. The anomaly also raises questions about the fundamental nature of reality. Could it be a localized distortion in spacetime? Might it represent a form of matter or energy not yet described by current physics? Its subtle influence on surrounding gas clouds and gravitational fields suggests interactions that extend beyond conventional understanding. These possibilities expand the scope of inquiry, allowing the narrative to blend scientific exploration with philosophical reflection, inviting viewers to ponder not only the mechanics of the universe, but also the nature of existence itself. Cinematic visualization continues to emphasize contrasts, scale, and tension. Explosive galactic activity unfolds in vibrant color and motion, while the anomaly pulses faintly, commanding attention through its subtlety. Light and shadow, chaos and calm, motion and stillness, all interact to immerse the audience. Tendrils of light weave through the surrounding material, faintly bending and interacting in ways that suggest hidden dynamics. This interplay reinforces engagement, allowing viewers to experience the drama, beauty, and mystery of the cosmos simultaneously. Ultimately, the anomaly exemplifies the intersection of observation, theory, and imagination. It challenges scientific understanding, inspires new hypotheses, and compels both researchers and viewers to confront the unknown. Through meticulous observation, rigorous modeling, and imaginative speculation, scientists attempt to unravel its mysteries, while viewers are invited to share in the wonder, suspense, and intellectual exhilaration of discovery. Cinematic storytelling amplifies this experience, combining visual spectacle with emotional resonance, ensuring that the anomaly remains both a scientific enigma and a source of profound inspiration. By the end of this section, the audience is left with a sense of anticipation and awe, aware of the anomaly's unresolved mystery and the vastness of the universe that contains it. The stage is set for further revelations, deeper investigation, and the possibility of paradigm-shifting discoveries. The anomaly is no longer just an object of study. It is a symbol of the infinite complexity, beauty, and wonder of the cosmos, compelling viewers to continue the journey of exploration alongside the scientists who seek to understand it. As the cosmic drama of the colliding galaxies unfolds, the anomaly observed by the James Webb Space Telescope becomes an enduring focal point of wonder, speculation, and discovery. After months and years of observation, its subtle luminosity, faint pulsations, and irregular energy emissions have persisted, resisting easy classification. In a universe dominated by immense forces, supernovae erupting in violent brilliance, tidal streams flinging stars across hundreds of thousands of light-years, and supermassive black holes emitting jets of high-energy particles, the anomaly remains quietly enigmatic. It is small in scale compared to the galaxies around it, yet its persistence, subtlety, and defiance of known physical laws elevate it to a position of extraordinary significance. This final section of the narrative examines the implications of the anomaly, its role in the ongoing pursuit of knowledge, and the profound emotional and philosophical resonance it carries. Cinematic visualization emphasizes contrasts that capture both scale and subtlety. The colliding galaxies dominate the visual field with spiraling arms twisting in luminous arcs, star clusters igniting with vibrant intensity, and clouds of gas compressing in explosive bursts of color. Against this backdrop, the anomaly pulses faintly, its tendrils of light weaving through the surrounding material like delicate threads. This juxtaposition of chaos and calm, explosive brilliance and subtle persistence, creates a visual metaphor for the narrative itself. The universe is both comprehensible and mysterious, governed by known laws yet filled with phenomena that defy understanding. The audience is drawn into this tension, experiencing both intellectual engagement and emotional resonance, captivated by the beauty, complexity, and uncertainty of the cosmos. The anomaly's continued observation has led to incremental insights, each deepening the mystery. Subtle shifts in brightness suggest internal dynamics or interactions with the surrounding interstellar medium, while spectral anomalies hint at a composition or energy state that remains unrecognized in current astrophysical models. Computational simulations incorporate gravitational forces, gas dynamics, and dark matter influences, yet no model fully reproduces the observed behavior. This iterative process exemplifies the scientific method: observation, hypothesis, testing, and refinement. Yet with each cycle, new questions arise, reinforcing the anomaly's role as both a puzzle and a catalyst for discovery. The persistence of these unanswered questions sustains narrative tension, keeping viewers intellectually and emotionally invested. Hypotheses about the anomaly's nature remain bold and varied. Some propose that it could be a nascent black hole, forming quietly in the gravitational turbulence between the galaxies and slowly accumulating matter while emitting irregular energy. Others suggest a concentration of exotic matter, a previously unobserved form that interacts weakly with ordinary matter and energy, detectable only under specific conditions. Another possibility is that it represents a transient phenomenon, visible solely during this stage of galactic collision, a fleeting glimpse of processes occurring over millions of years. Each hypothesis challenges existing paradigms, forcing scientists to consider new physics and theoretical frameworks, and ensuring that the anomaly remains a symbol of the universe's limitless complexity and mystery. Philosophically, the anomaly embodies the tension between knowledge and mystery, comprehension and wonder. Its subtle glow amidst violent galactic activity reminds humanity that even with advanced technology and centuries of accumulated understanding, the universe retains aspects that elude explanation. This realization evokes humility, fascination, and awe, compelling viewers to reflect on the scale, complexity, and beauty of the cosmos. Cinematic storytelling reinforces this philosophical dimension, portraying the anomaly's quiet persistence against the backdrop of explosive events, creating a visual metaphor for the enduring human pursuit of understanding amidst the vast unknown. Temporal dynamics add further complexity. Observations over extended periods reveal small but meaningful changes in luminosity, energy distribution, and structural features. These variations suggest ongoing processes or interactions, possibly involving forces or matter not yet fully understood. Scientists track these dynamics meticulously, using multi-wavelength imaging, spectral analysis, and computational modeling to capture and interpret subtle shifts. Each data point informs hypotheses, refines simulations, and raises new questions, reinforcing the iterative nature of scientific discovery and the narrative tension that drives engagement. Viewers are immersed not only in the spectacle of the cosmos but also in the human endeavor to comprehend phenomena at the frontier of knowledge. The anomaly's relationship with its environment is particularly striking. Colliding galaxies generate immense gravitational forces, shock waves that compress gas clouds, and tidal streams that fling stars into elongated arcs. Yet the anomaly maintains coherence and subtle influence, suggesting stabilization mechanisms or interactions that are not yet understood. Could it be a localized pocket of spacetime, a form of matter or energy outside current models, or an entirely new phenomenon? These questions underscore the mystery and intellectual challenge, offering narrative hooks that sustain curiosity and emotional engagement. Cinematic visualizations highlight these contrasts. Explosive energy and quiet persistence, motion and stillness, chaos and subtle order, creating a compelling visual and conceptual experience. Scientific collaboration is central to understanding the anomaly. Observatories worldwide coordinate observations, share data, and compare findings to ensure accuracy and comprehensiveness. Multi-wavelength imaging captures information across the electromagnetic spectrum, from infrared to X-ray, while computational models simulate environmental interactions and test theoretical predictions. This global, collaborative approach mirrors the narrative's thematic tension between known science and unexplained phenomena, emphasizing both the rigor and creativity inherent in the pursuit of understanding. Viewers are offered a glimpse into the real-world processes that transform observation into knowledge, highlighting the dedication, patience, and ingenuity required to study the unknown. The anomaly challenges assumptions about galactic evolution and the behavior of matter under extreme conditions. Traditional models predict star formation, gas compression, and gravitational interactions during galactic collisions. Yet the anomaly's persistence and subtle influence suggest additional processes at work. By defying expectations, it serves as a catalyst for theoretical innovation, prompting scientists to expand existing models, explore new physics, and consider previously unimagined possibilities. This narrative thread emphasizes the frontier of human knowledge and the continual evolution of understanding, ensuring that viewers remain engaged both intellectually and emotionally. Cinematically, the anomaly's subtle glow amid the violent galactic tableau evokes wonder and suspense. The interplay of light, motion, and contrast emphasizes its enigmatic nature, drawing the audience's eye and imagination. Tendrils of light pulse faintly, interacting with surrounding gas streams in unpredictable ways, suggesting hidden dynamics or forces at work. Explosive star formation, supernovae, and tidal distortions provide dramatic visual context, heightening the emotional impact of the anomaly's persistence. This combination of spectacle and subtlety ensures that viewers remain deeply immersed in the narrative, experiencing both the grandeur of the cosmos and the mystery of the unknown. Emotionally, the anomaly captivates through its quiet defiance and inscrutability. Its persistence amid chaos symbolizes both the beauty and the complexity of the universe, evoking awe, curiosity, and a profound sense of scale. Cinematic sequences enhance this emotional resonance. The violent motion of colliding galaxies contrasts with the anomaly's subtle pulse, creating a rhythm of tension and release that mirrors the intellectual challenge of discovery. Viewers are invited to share in the wonder and suspense, experiencing the excitement, uncertainty, and philosophical reflection that define humanity's encounter with the unknown. Ultimately, the anomaly represents the intersection of observation, theory, and imagination. It challenges understanding, inspires hypotheses, and compels both scientists and viewers to confront the limits of knowledge. Through meticulous observation, rigorous modeling, and imaginative speculation, researchers strive to unravel its mysteries, while viewers are immersed in a narrative that combines visual spectacle, scientific insight, and philosophical reflection. The anomaly becomes a symbol of the enduring human quest to comprehend the universe, illustrating both the achievements of science and the vast, unexplored frontier that lies beyond. As the final act of this cosmic narrative unfolds, the anomaly stands as a testament to the universe's grandeur, complexity, and mystery. Its subtle glow amid the violent collision of galaxies embodies the tension between order and chaos, the known and the unknown, comprehension and wonder. Through cinematic visualization, detailed scientific explanation, and philosophical reflection, viewers are left with a sense of awe, curiosity, and anticipation, aware that the universe contains phenomena that challenge understanding and inspire imagination. The anomaly is no longer merely an object of study. It is a symbol of humanity's enduring pursuit of knowledge, a reminder of the infinite possibilities that lie beyond the limits of perception, and a beacon guiding the ongoing journey of discovery across the cosmos.